What's up, y'all? Today we're going to be going over separable equations and how to work these out. They're just differential equations that look like, basically, it's an easy way to explain it, y prime equals, we'll do this, x to the fourth over y. And what this means, how you can solve this is if you can get both sides if you can get one side multiplied by dx and the other side multiplied by dy, you can just integrate both sides, and then it will give you a solution. Right? So we know that y prime is equal to dy over dx, or the same thing, right? Equals x to the fourth over y. So basically the question is, how can we get y and dy together and dx and the x, all the x's together, right? Sometimes you can't. In this case, you can. This is a separable equation. So what are we going to do? We're going to start by multiplying each side by dx, right? So we're going to multiply this side by dx. We're going to multiply this side by dx. And what that's going to do, these are going to cancel because that's dx over dx, which is just 1. And then you're left with dy equals x to the fourth dx over y. Well, now you can also multiply both sides by y, right? To get y on this side. That's the goal right here. So y, and then this goes away, right? So now we have y dy equals x to the fourth dx. Now we can integrate both sides. Typically, I don't worry about the constant of integration on the left side. I only worry about it on the right side, because if you just add two constants together, you're going to get another constant. So you can just call it c for one side, right? So let's do the integral of both sides, right? Well, we're going to integrate, and this is going to be 1/2 y squared. Here, it's on the left side of the equation, so I'm not going to worry about the c for this side. I'm only going to worry about the constant of integration for this side of the equation. So 1/2 y squared equals, well, 5, so like that's 1 over 5, 1 over 5 x to the fifth, plus the constant of integration, right? So now you could, I know for the book, the answer, it says y squared is, I think the answer, what is the answer? It's y squared equals, yeah, so basically what they did was just multiply both sides by 2. So 2, and then that's going to give us, I'm going to erase this work up here real quick and write it above. So this is going to give us 2 over 2 is just 1, so y squared equals 2 over 5 x to the fifth plus c. Twice c, we don't know what c is, so twice c is still just going to be some constant. If you'd like, you can call it k. It's the same thing, but I just like to call it c. Because in this case, we're not being specific with what c is going to be. Later on, when you have to like find c, you have to start being more specific about it. But in this case, it's fine. So this is going to be your answer, is y squared equals 2 over 5 x to the fifth plus c. What some people do is they just solve it for c, right? So y squared minus 2 over 5 x to the fifth equals c. That's not really necessary. My teacher wasn't strict on it, and I don't think that most people are going to be when I took this class. So this is going to be the answer for the. It's going to be the answer. That's the solution. So let's do another separable equation, and so y prime equals x squared over y times 1 plus x cubed. So if you'd like to pause the video and try and work it out by yourself, it's totally fine, or you can work it with me, either way. So let's start by changing this to dy over dx. So we have, dy over dx equals x squared over y times 1 plus x cubed. So what we can do to start off with is we can multiply each side by dx, right? And we can also multiply each side by y. I'll just do it one step at a time to make sure that you're following along. So we're going to multiply each side by dx. So dy equals x squared dx over y times 1 plus x cubed. So now what we can do is, and I'm actually going to move this dx to the outside, make it a little bit, so we can see a little bit better. Okay, so now let's take care of the y, right? We have everything in terms of x on the right side except for this y, so let's multiply both sides by y. So these go away, and then we're left with y dy equals x squared over 1 plus x cubed dx. So now that we have everything on the left, which is dy, the left doesn't have to be dy, but in this case it does because dy is on the left side of the equation. Everything on the left is in terms of y, and everything on the right is in terms of x, which is what we want. And now we can rewrite this equation, or we can take the integral of both sides. So let's do that. Take the integral, and this is going to leave us with 1/2 y squared again. And then this is going to be the integral of x squared over 1 plus x cubed dx. So this is going to be a little bit longer. We're going to have to use just substitution here. So let me erase this, and then I'll rewrite the equation up here. So 1/2 integral . Okay, so what do you think would be the best thing to set as our u sub? Well, my guess would be that 1 plus x cubed would work pretty well, because the derivative of 1 plus x cubed is going to be 2x or 3x squared, and that's going to cancel our numerator term, right? So for the right side, this is just calculus. I think maybe the end of calculus 1. I'm not sure. It's either the end of, you learn this at either the end of calculus 1 or beginning of calculus 2. So let's set u equal to 1 plus x cubed, and then we'll take the derivative of it. So the 1 just goes away, and then you're left with 3x squared. So now let's go ahead and perform our substitution. So 1/2 y squared, we're leaving that side the same. So now we can substitute, sorry, so it's going to be dx. I always forget to do that. I just do it in my head sometimes. Okay, so now we want to solve this for dx. Dx equals du over 3x squared. So now let's go ahead and plug this all in, right? So we'll say the integral, and the goal of this is to get it in terms of u. Just a little refresher. So the integral of x squared over, well, we set u equal to 1 plus x cubed, so let's leave it like that. X squared over u now because of this substitution. And then we're going to plug in, for dx, we're going to plug in this du over 3x squared, and that is going to, the x squareds are going to cancel. Now we have just a integral in terms of u, but it's 1/3 of, going to be dividing by 3. So we'll pull this 1/3 out. 1/3 the integral of 1 over u du, right? And the integral of 1 over u is going to be a identity, but it's the natural log is going to be the integral of 1 over u. So let's go ahead and do 1 over 2 y squared equals 1 over 3 times the natural log of u. It's going to be the absolute value of u, because we have that cubed term in there. Yeah, we'll have a cubed term in there. The absolute value of u plus c, right? Can't forget our constant of integration on the right side. So now let's go ahead and multiply both sides. We'll go ahead and plug u in. are 1 plus x cubed. So 1 over 3 natural log 1 over 3 natural log of 1 plus x cubed. And it has to be the absolute value because x cubed can be a negative. If you were to plug in -2, that would give you a negative inside of a natural log, and you can't do that. It's illegal. So plus c. And that should be your answer. You can tidy it up by like multiplying both sides by 2. I don't know if the book did that. Yeah, the book does do that. It doesn't really matter though. It's going to be the same thing. So you're going to multiply both sides by 2, and you're going to wind up with y squared equals 2 over 3 natural log of the absolute value of 1 plus x cubed plus c. And there's your answer for this problem. It's not really working that well. Okay, so let's do another one. Do 2 more, and we'll take a little break. And I'll come back with some more separable equations. This is more of a the purpose of these YouTube videos I'm doing is more for like practice. It's not gonna carry a lot of concepts. I'll probably like prove like integrating factor and some other stuff, but it's mostly gonna be like about practice. That's what most of this course is. It's very important to understand the concepts, but that's not gonna be. I'm not gonna try to explain concepts. I'm not teaching the course. I'm just trying to be here for you for like supplementary practice. So let's try another equation. So this one's going to be y prime plus y cubed sine of x equals 0. Okay. So this one looks weird, right? Because you have all the terms on one side of the equation, and then you have a 0, right? You can't integrate 0. Well, we have this plus sign, which works out for us, right? What we can do is we can do y prime equals negative y cubed sine of x, okay? So now we don't have any addition or subtraction, which works out nice. Sometimes it's okay when it's like multiplied by the whole, like the whole thing, that's fine. But if it were to be like 1 plus x cubed, then you'd have like a y plus 3 or something. Like it doesn't. It's sometimes it's not. I don't think this is separable. Y prime. It's probably not going to be a separable equation. But in this case, it works. You can tell because there's typically no addition or subtraction. That's how you can like tell it's going to probably be separable in the first part of the course. So let's change this to dy. Actually, instead of writing a whole new line, I'm just going to erase this y prime and change it to dy over dx. dy over dx is going to be used a lot in separable equations. You'll start y prime will be more prevalent the further you get into the course. So let's do. So how can we get them on both sides, right? How can we get dx associated with all the x terms and then dy associated with all the y terms? Well, let's go ahead and leave the negative on this right side of the equation and multiply both sides by dx. So we're going to be left with dy equals negative y cubed sine of x dx. Well, we're not ready to integrate yet because we have y and x on the same side. So let's divide each side by y over 3, right? Or sorry, y to the third power. Which is the same thing. I hope you understand that it's the same thing as y to the negative third, but I'll just do it like this. So we're going to divide this by y to the third, divide by y to the third. So what you actually have is 1 over y cubed equals negative sine x dx, right? You can write it like 1 over y cubed equals y to the negative third power. That's fine. It doesn't really matter. Oh, whoops. I didn't put my didn't leave my dy up here. Sorry, dy over, yeah. So now everything is separated, is into a form where we can integrate both sides and find our solutions. So let me erase this. And we're going to copy this up here. I'm going to do 1 over y cubed times d. Looks like, let's do it like this. 1 over y cubed times dy equals negative sine of x dx. And now we can integrate both sides. And when we integrate, it's going to give us our solution. So integral, right? And remember, don't worry about the constant until the right side of the equation. So the integral of 1 over y cubed is going to be what? That's why I like to change it to y to the negative third. It's a little bit easier to work with when you're dealing with integrals. I mean, it's easier for me. It just depends on what type of brain you have. So y to the negative third times dy, right? So when we integrate this, we basically add 1, right, to negative 3. And so we're going to get negative 1 over 2 y to the negative second, right? So when we take the derivative of this, we'll wind up with this, negative 2. So that goes down, yeah. So then this equals negative sine x dx. Well, what's the integral of negative sine of x? It's going to be positive cosine of x. And then don't forget your constant of integration. So this will give us, so if you want, you can multiply both sides by 2. Actually, I think, negative 2. And then you'd be solving for, it's just getting it like nice and neat. You'd be doing 1 over 2 y to the negative second minus cosine of x equals c. You're going to see it like equals c a lot for the separable equations. And you basically multiply both sides by, or you multiply everything by negative 2. But 2 times c is just equal to k, so you really don't have to worry that we're not getting into specifics right here. So this will be fine. So we're going to multiply it by negative 2, and this is going to be y to the negative second power plus 2 cosine of x equals c. And that's going to be the answer for this one. Okay, so let me see how much time we have on this recording. Okay. Let me go ahead and pause it right here, and I'll start another one, and we'll do the rest of these. Alright, we're in the second part of this separable equations video, so we're going to go ahead and solve this problem right here. Now, we can turn this y prime again into dy over dx. Let's do that. So now basically how are we going to get everything, each in terms of its own type of variable. So let's go ahead and multiply by 7 plus 5y on both sides. That's an ugly 5. So that's going to give us 7 plus, it's kind of going out on me. So 7 plus 5y dy over dx equals, the 7 plus 5y, each side is going to go away, right? So we're left with 7x squared minus 1, right? So now we can multiply both sides by dx. And I'm just going to do that, like erase this, like that. So we just multiplied by this side, both sides by dx. The dx goes away right here because dx over dx is 1. So we have this equation right here. So now we are free to integrate both sides. So let's go ahead and do that. So the integral of 7 with respect to y is just 7y. The integral of 5y with respect to y is 5 over 2 y squared, right? And then we're not worried about plus c yet because we worry about that on the right side of the equation. So 7x squared, the integral of that is going to be 7 over 3 x cubed minus x plus c, right? So you can like find a common denominator or whatever. Just multiply everything by what, 6, right? Yeah. I don't think it really matters, but let's go ahead and do it anyway because I think that's what the answer says in the book. Yeah. So in order to do this, let's get everything away from c. So we're left with 7y plus 5 over 2 5 over 2 y squared minus 7 over 3 x cubed minus plus x equals c. I'm going to copy that up here. So now we can multiply this whole thing by 6. Remember, 6c just equals some other constant k. We're not worried about it right now. Yeah, we're just not worried about it right now. You'll see later. So 6 times 7 is 42y. 6 times 5 is 30, over 2 is 15. So 15y squared. So minus 6 times 7 is 42 over 3. I'm going to cheat on this one. 14. Is that x? Yeah, 14x cubed. And then plus 6x. I think that's right. We'll see. 6x. Yeah. Yeah, so this will be your answer. Alright. So this is going to be the solution when it asks you to solve this differential equation. So let's do another one. Let's see, xy prime equals 1 minus y squared to the 1/2 power. Okay, so let's go ahead and change this y prime to dy over dx. If you're lost on why I'm doing that, you have to do it for separable equations to get dy and dx, but y prime, they're just two different notations of the same thing. Y prime is the same thing as dy dx. They're both two different notations of how to represent a derivative. So now how are we going to do this one? Well, we have x and dx on this side, right? But the dx is the denominator, and that's bad. So you'd have to have dx in the numerator. What I can do is I can divide both sides by, actually let's divide both sides by x first. So dy over dx equals 1 minus y squared to the 1/2 power over x. And then what we're going to do is we're going to multiply by both sides by dx, because the dx has to be in the numerator. So dx over dx is just 1, so we're going to erase this. Now we got to get y, this 1 minus y squared to the 1/2 power. We gotta do something about that, right? So let's go ahead and divide both sides by, so we're going to be dividing by 1 minus y squared to the 1/2 power, which multiplying by the reciprocal is the same thing, right? So this is actually going to come over here. 1 minus 1 over 1 minus y squared to the 1/2. So this is going to be 1 over 1 minus y squared to the 1/2. We'll just do we'll go ahead and just use a square root right here, because that should look pretty familiar to you. Yeah. So this times dy equals 1 over x dx, because these cancel whenever you're multiplying by its reciprocal. So I'm going to erase all this work up top, copy this up here, and we'll keep going. So we have 1 over the square root of 1 minus y squared dy equals 1 over x dx. Now, from calculus 2, you should remember there is an identity. We're gonna be able to take the integral of both sides here, because this left side is all in terms of y, the right side is all in terms of x. We've got dy on the left, dx on the right. So let's go ahead and integrate both sides. Now this, you should remember from calculus 2. It's a inverse trig identity, and I believe it is inverse sine. Is that right? Yeah. So it would be inverse sine of y. So sine inverse y is going to be this integral right here, and we have this equal to the integral of 1 over x is going to be the natural log of x plus c. X, and for this, x has to be greater than 0 because of this limitation. This limits what x can be. So now what we can do is we can take. So this is a sine inverse of y, right? So how are you going to undo sine inverse? Well, what you can do is you can just take the sine, right? Sine of this, and then these two cancel, and you're just left with y. But if you do that to this, you're also going to have to do that to this side. So we're going to have sine of the natural log of x plus c, just like that. These go away, and you're left with y equals sine the natural log of x plus c. And that's going to be your answer. Hope you can see that. So, alright, I'm going to go ahead and erase this, and we'll do a couple more. Okay, so let's see if y'all can see this one a little bit better. Alright, I got another kind of tricky one for you guys. We're looking at y times dy over dx equals x plus x y squared times e to the x squared. So what we can do here is factor out an x in this to get this inside part just in terms of y. So y dy over dx equals 1 plus y squared times x e to the x squared. Now we can divide both sides by 1 plus y squared. So we're going to have y over 1 plus y squared dy over dx equals x e to the x squared. Now let's multiply dx. Let's multiply by dx on both sides. So the dx on the left side will cancel and go over here. So now we have everything in terms of y on the left side, everything in terms of x on the right side, because dy is on the left side, dx is on the right side. So now let's go ahead and integrate. And when we do this, For this, we can use a u sub, set u equal to 1 plus y squared. So when we do that, we will get we'll take the derivative of u, just a simple substitution. The integral, or the derivative of 1 is just nothing, and then the derivative of y squared is 2y dy. I will solve for dy. So that's du over 2y, right? And then let's go ahead and rewrite this integral. And let's rewrite it as y over u, because we set u equal to 1 plus y squared. And then dy is equal to du over 2y. And that's equal to the integral of x e to the x squared dx. Now, if you'll notice, the y's cancel out, so that works out nice, and we're left with a 1 over 2, we're left with a over 2, so let's just pull that out front, erase this. So we're left with 1 over u du equals the 1/2 the integral of 1 over u du equals the integral of x e to the x squared dx. So let's bring this back up top, and we'll erase this. So actually we need that u is equal to 1 plus y squared still. Just remember that. So now we can do 1 over 2 times, well, the integral of 1 over u du is just going to be the natural log of u, which in this case u equals 1 plus y squared. We don't need the absolute value sign because this will never be negative for whatever value of y you put in. So instead of putting the natural log of u, I'm going to put 1 plus y squared. And that's the integral of this. We're not worried about the constant on the left side, again, remember. We're only worried about the constant on the right side. So now we have the integral of x e to the x squared dx. Well, this looks like it could be parts, but if you try and set it up that way, you're going to want u equal to x, and then dv equal to e to the x squared. And you would have to integrate this, and I believe that that is that's a function that's not integratable. So that's no good. So we're just going to have to use regular substitution. And we'll set u equal to x squared in this case. Take the derivative, du equals 2x dx, and then solve for dx. dx equals du over 2x. So now let's come back and rewrite this integral. So 1 over 2 natural log of 1 plus y squared equals, well, we have the integral of x times e to the u, and then dx is going to be du over 2x. So we're going to be able to pull a half out, and these x's are going to cancel. Numerator, denominator. So erase this, and then we're left with a 1 over 2. So now we're left with 1 over 2 integral of e to the u du. Okay, so that's something we can work with. So we'll leave that u equals x squared, and then we'll rewrite it as 1 over 2 natural log 1 plus y squared equals 1 over 2. The integral of e to the u is just e to the u, but we know that u equals x squared, so we're going to leave it like this. Okay, so now this is when it gets a little bit weird. We can multiply both sides by 2, and these just go away, right? So now what we can do is we can raise both sides to the power of, we can exponentiate. So just basically go like this, right? So when we do that, the natural logs cancel, and we're just left with 1 plus y squared equals e to the x squared, I know it looks weird, plus c. And that is going to be your answer right here. Alright, so I'll be right back. I'll probably do 2 more for you. Alright, I got 2 more for you here on separable equations, and we'll probably move on. So y prime equals x squared over 1 plus y squared. what we can do here is we can rewrite this y prime as dy over dx. Right, and then we're going to multiply by dx and multiply by 1 plus y squared, and that's going to give us 1 plus y squared dy equals x squared dx. We can integrate both sides because it's now separable. We have all terms of y on the left, all terms of x on the right. So now to integrate this, this integral is going to be y. The integral of 1 is y. The integral of y squared is 1 over 3 y cubed equals 1 over 3 x cubed plus c. So let's multiply everything by 3 and move this 1 over 3x cubed over. So we're going to have 3y plus y cubed minus x cubed equals c. And that's going to be your answer. So that's for this one, and then I'm going to do one more. Yeah. So dy over dx equals secant squared of x over 1 plus y cubed. Yeah, okay. So now we'll do the same thing. We're going to multiply both sides by 1 plus y cubed. And then we're going to multiply dx over to this side. So now they're both integratable because we have y in terms of, only terms of y on the left, only terms of x on the right. So now we have the integral of 1 again. The integral of 1 with respect to y is just y plus 1 over 4 y to the fourth equals, well, the integral of secant squared of x is that's a trig identity. The derivative of tangent is secant squared. So this is going to be tangent of x plus c. Multiply both sides by 4 if you'd like. I think they do that. Oh no, they don't. So let's see. Yeah. So now we can just move this tangent over. Y plus 1 over 4 y to the fourth minus tangent of x equals c. And I think that's the answer the book has. Make sure I have the answers written down, like not the solutions, but just the answers, so I can just check and make sure that I'm doing it right. So, yeah, okay. So this is going to be your answer. So I think that's all I'm going to do on separable equations. I will figure out what I'm going to do next. What I would like to show you guys. That was pretty much separable equations. Anytime that you have equations that are separable like that, you can integrate both sides and solve the differential equations that way. So thanks very much.